Assalamu alaikum students, welcome to our channel. Today we are going to start some questions, the important questions regarding the papers. If you can see the question number one, yes. In this question number one, they ask you to prove that the triangle PQR is a right angle triangle, or this side makes the 90-degree triangle. Okay. For this, we have to prove that this angle is going to be 90 degree. So I have only way that I can prove is first I'm going to take the square of each side means 174 square. Okay, let's write down the square of 174. It's going to be 302,763,0,276. Now find the square of 126. Let's take the square of 126. It gives you 15876. 15876. And the very big question comes to our mind that why we are taking the square of each number. If you remember that if it's a right angle triangle, this triangle must fulfill the Pythagoras theorem. And for the Pythagoras theorem, every side must be squared. And the two smaller side added, the sum must be equivalent to the third side. And this is what we are going to check here. Let's take the square of 120. The square of 120 is 14,400. Now, what I'm going to do, I'm going to take this, I'm going to add these two terms. Means I'm going to add 126 square and 120 square. This gives me 15876 plus 14400. Let's add them together. It's 15876. It's going to be 302276. Yes. As you observe, the sum of the two squares is equal to the third one. Means what I observe that Q is QR square plus the PR square is equals to PQ square, which fulfills the Pythagoras theorem. If you remember the Pythagoras theorem, it says h square equals to p square plus b square. Means yes, the given triangle is a right angle triangle and the side angle PRQ is the 90. Now the question is why, how can I say that this angle is going to be 90? Because the hypotenuse, the longest side always be the hypotenuse and the side must be the opposite to the 90-degree angle. That's why it's a PRQ, it's a right angle triangle. The second thing is how do I calculate the area of quadrilateral PQRS? For this, I can see two triangles and I need to add the two areas of the two triangles. But the question is, in the second triangle, I must have the side SR or must have PS. So let's calculate the two side, either PS or RS. The question is, how do I calculate the two sides? Let's decide. If you notice that the side PS is your opposite and the side RS is the hypotenuse. It means the third side, which is 126, is going to be the adjacent. Means I can use any trigonometric ratio in which I may involve the hypotenuse or the opposite. Since I decide to calculate the length of RS, which is the hypotenuse. So hypotenuse and adjacent. So adjacent over hypotenuse, yes. This may lead me to the ratio of cos theta. So cos theta means theta is 53 degrees. My adjacent is 126 and the hypotenuse, which is SR, is not given. To get SR, we must divide the two terms, 126 by cos 53. Let's calculate. So it's going to be 126 divided by cos 53. Yes, it gives me 209. It's 209.366. Now, how it helps me in calculating the area of the triangle? Let's see. I'm going for the area of triangle PRS. And I'm using the formula. Yes, the important thing formula. So area is going to be 1 over 2 times A times B times sine C. Now, the two sides, yes, I can pick 126 and I can pick 1 over 2 times 126 times 209.366 times sine. Remember, in case of triangle, if you're looking for the area, angle must be subtended between the two sides. That's 53. So let's calculate the area. It's going to be 0.5 times 126 times 209.366 times sine 53. Yep. It gives me the area 10534.048. Now calculate the area of the second triangle. That is area of triangle PQR. Using the same formula, we calculate the area. We have two sides, 126 and 120. Why? Because as you can see, the angle between the two sides is 90. We just found it. So sine 90 degrees. So let's calculate it. 5 times 126 times 120. That is 7560. 7560. But the area of the whole shape, area of PQRS. We must add the two areas. The first one was 10,534.049 plus 7560 plus 10,534.049. It's going to be 18,094.049. But in three significant figure, the final answer will be 18100. This is the final answer, the area of the whole shape. This is the way we use the trigonometry in different situations. Please note it down carefully, so I may move on to the next function. Okay, now move on to question number 2. It's a rectangle and OPX is a sector with the center O. So as you can see, the other side of the rectangle means this one is going to be 4 centimeters as well, which is the radius of the sector as well, means the length of OX will be 4 centimeters as well. Since I'm looking for the area of the shaded region, means I must get the area of rectangle, then I will get the area of the sector, and then I'm going to subtract the two areas. So let's get the area of rectangle first. Area of rectangle. I hope you remember the formula length times width. The length is 11 centimeters, width is 4 centimeters, so the area will be 44 centimeters square. That's the area of the rectangle in which shaded region and unshaded region both are included. So I have to remove the area of the sector. But for this purpose, I must have this angle which I don't have. With this angle, I'm going to use the triangle. If you look at the diagram, I've picked a triangle from this diagram, a right angle triangle, and the name of the triangle is OP and Q. This is 11 centimeter long and this is 4 centimeters long. And I'm interested in this angle. So the side 11 is going to be the opposite and this side is going to be adjacent. Means I must use tangent. Yes. So tangent theta is equals to opposite, which is 11, and the adjacent is 4. Since we are looking for the angles, that's why we must use the inverse function. As you remember, how do I get the inverse function? We press shift button and then press tangent. When you do so, what happens? You will see like this on your screen. And what you do in the bracket, you write 11 divided by 4. This will give you the angle theta. Let's calculate angle theta. What is going to be the angle theta now? Shift tan inverse 11 divided by 4. This is going to be 70.0 or 70. Both are correct. Now, to get the area sector, so area of sector. The formula is theta upon 360 multiplied by pi r square. We just found theta, which is 70 degrees, divided by 360 times 3.142 times radius, and the radius is 4 centimeters square. I told you in every class that we must use pi as 3.14 to avoid to use the whole pi as a value. Oh, please, because it sometimes disturb the accuracy level as well. That's why we avoid the complete value of pi. So this is going to be the area factor, which is 3 point, oh sorry, so 9 point, I'm really sorry. It's 9 point, not 3 point. It's 9.775. Since it's not a final answer, that's why my accuracy level is going to be very high. We always try to make it around 4 significant figure or 5 significant figure so that the final answer will be the accurate one. That's going to be the area of sector. Now we move on to the area of the shaded region. Yes. So area of shaded region. For this, yes, I must subtract the area of sector from the area of rectangle, which is 44 minus 9.775. So 44 minus answer, this is going to be 30 minus 30.232. 30.232. This is the area of the shaded region. But look it carefully, they ask you the percentage as well. Yes. For the percentage, we must divide the area of shaded region by the area of a rectangle, which is 44 times 100, which they mention here as well. Divided by 44, multiplied by 100. Yeah, it's going to be 60. Oh, sorry, I don't know what it is. 30.232 times 100 divided by 44. Yeah, it's going to be 68.79. That's the area of the sector or area of the shaded region as a percentage of the area of rectangle. Please note it carefully. Let's start the question number 3. In this question, they ask you to find the length of AC. Okay, first, let's draw the line AC, and what we can see from this diagram, if I join A and C, yes, this is the line AC. And what I found, I can see a right angle triangle here. It's a 90-degree angle. It means yes, very good. Pythagoras theorem, absolutely right. And the Pythagoras theorem says that h square is equals to p square plus b square. As I mentioned earlier, in Pythagoras theorem, the only important thing is the right selection of the hypotenuse. And a hypotenuse is a side which is in front of the 90-degree angle, which is line AC. So write AC with square, whereas perpendicular base P or B, it could have been any side. I write 18.6 square plus 9 square. So AC square is equal to, let's calculate the two lengths. Let's get the square. Let's add them together. So it's going to be, let's see how much it's going to be, 18.6 square plus 9 square, right? It's 4 to 6.96. 4 to 6.96. To get the length of AC, we must take the square root on both sides. 0.96. Square root. So the square root of 4 to 6.96. Yeah, it's going to be 20.663663. But in three significant figure, I must write the form of 20.7. Yes, this is the correct form of AC. In the next part, they ask you to find the angle between the base of the box and the AM. Yes, means they are looking for this angle, theta. And this must be the 90-degree angle. Yes. So it means this is my opposite, and this is going to be the adjacent. Yes, you're right. We will use the ratio of tangents. Tangent theta is equals to opposite over adjacent. The opposite is 14.5 and the adjacent is AC, which we just calculated here. Now, important thing is, since I'm using the AC, to always try to use the original value. not the approximated answer. Avoid the approximated answer. It may disturb the accuracy level. Since, yes, we're looking for the angle, means we'll take the tangent inverse. 6, 6, 3. Yes, you're right. Here, oh, let's start with this tan inverse. Yep, tan inverse. It says 14.5 divided by, oh my God, sorry, 14.5 divided by 20.663. So the angle is 35.058. According to the rules or the instruction of the paper, your angle must be in one decimal place. So theta is going to be 35.1 degrees. Except angle, every calculation, every answer must be in three significant figures. Right? So please note it very carefully. Then we move on to the next question.